Hey guys, so today we're going to go over background 6 magnetic fields. So the first thing is a magnetic field is the region around a magnetic material in which the movement of electric charge causes force on the electric charge. That'll make more sense as we go through the rest of this. So the magnetic force is given by the F equals QVB sine theta, where theta is the angle between the velocity and the magnetic field, and the direction of this force is given by the right hand rule for the force, which isn't discussed in this PDF because I couldn't find a good picture that I liked. So I'll talk about it here though. So if we have a magnetic field to the right and then a charge moving directly up with velocity, then the magnitude of magnetic field, so in this case the angle between them is 90 degrees, so the force is QVB sine theta, but since theta is 90 then sine of theta is 1, so QVB is the magnitude of force. And to find the direction of the force, we point our fingers in the direction of the magnetic field. So in this case I point my fingers to the right, then you curl your fingers in the direction of the velocity. So I'm looking at this paper, I curl my fingers to the right, or point them to the right, curl my fingers forward because that's the direction of the velocity, and my thumb points straight up, so the magnetic force is directly out of the page. If Q is a negative charge, then we do the same thing and then flip it, so the force is directly into the page. We show that with this symbol. So this dot is out of the page, and this so for one more example, if the magnetic field is into the page and the velocity, then I point my fingers in the direction of the magnetic field, which for me is into the page, then the velocity is going forward in front of me, so I curl my fingers in front of me, and then my thumb is pointing to the right, so the force on the charge is to the right if it's positive, and to the left if it's negative, or if the charge is negative. Yeah, that's all there is to it. I guess one more harder one is if the magnetic field is in that direction, but the velocity is here, and we say that this angle is 30 degrees, then the force, I point my fingers in the direction of the magnetic field, curl them in the direction of velocity, my thumb points straight up, so the force is out of the page, and then the magnitude of the force is QVB sine 30 degrees, which is QVB over 2. Okay, now for the next part, the magnetic field generated by a current. So a moving charge generates a magnetic field, and if we have a current, all it is tons of moving charges. If I say we have a current moving forward, the direction of the magnetic field wraps around the current. Using your right hand, if you point your thumb in the direction of the current, the magnetic field wraps around the current. So we have the magnetic field into the page over here, and out of the page over here, and then to the right over the magnetic field, and underneath it goes to the left. So what this looks like in real life is I have this wire, and the current is traveling from here, the current is going to the end over here because it's charging my laptop. Then the magnetic field wraps around the wire according to my thumb, or according to my fingers when my thumb is aligned with the current. So my thumb is pointing in the direction of the current, because it's traveling to this end, and then my fingers wrap around the current, then the magnetic field is in the same direction as my fingers. And you have to use your right hand for this. It's my right hand. So the current, or the magnetic field, is directed around the wire in this direction. That's all this picture is supposed to show. It'll look like that. Then the magnitude of magnetic field is given by, where r is the distance from the current. So the magnetic field here. So that's the magnetic field of this point way out here, due to that current. And just note that this mu o is 4 pi times 10 to the negative 7. The magnetic field inside of a coil. So the direction of magnetic field inside of a coil is actually the same, or is a result of the previous thing that we learned. So if I wrap this coil in a loop, and I say the magnetic field points, or the current runs to this end, the current moves towards this end, then if I point my thumb in the direction of the current, then the magnetic field wraps around the wire in this direction. And that'll occur for all points on this wire. I recommend you just do this by yourself at home. You'll see. It might look a little bit silly, but once you do it, you'll understand that the magnetic field points out of the page within the coil and into the page outside the coil. And the strength of the magnetic field at the center of the coil is given by B equals N mu O I over 2R. And N is the number of turns of wire.